Good day to you all. In this session, we are going to discuss about the different computational models. Fine. So in the computational models, there are different models are available. So these computational models are going to give how my data is processed, the computation, what is actually the modeling of that computation, right? Say for example, there are different models are available. One is called as data flow graph model. The second one is control data flow graph model. The third one is state machine model. The fourth one is sequential program model. The fifth one is concurrent or communicating process model. And the sixth one is object oriented model. I think you might have studied almost all these things, right? Maybe the word may be different, but we have the basic concepts of what are different types of models, especially object oriented programming. You should be knowing it. The concurrent or communicating process model, where I can take the data, process it, and immediately send the back data, right? So that is the again there. The sequential program, of course, any program you write in any system language, something like C program or CPP program, everything comes under the sequential programming model. State machine, already you might have studied in your digital circuits, and how to design a state machine model for the given embedded system application. Then data flow graph and the control flow graph are a normal data processing mechanism, right? So we will see just one by one, of course. The first one is actually the data flow graph or diagram model. Here actually what does it say is it is going to translate the data processing requirement to a data flow graph. So the data is coming inside and how the data is getting processed and how the data goes out of the system. And it's a data driven model in which the program execution is determined by the data, right? This model emphasizes on the data and operations on the data which transforms the input. So it takes the data and processes the data and gives out the output data. And the embedded applications which are computationally intensive or data driven are modeled using this DFG. So when there is no data is available to process, no system should work. Whenever there is data to process, the system should work. So it's actually basically a data based system, right? Based on the availability of the data, it will be working. And the DSP applications are typical examples for this. And this data flow graph is actually a visual model, right? So it will be using some sort of diagrams, right? And in order to represent a data flow. So there are two things are there. One is actually called as the process, which is generated using a circle shape, right? And how the data flows, that is represented by arrows, right? And an inward arrow means the data is coming as an input. The outward arrow means the data is going from that block as an output. And suppose we have taken an expression, something like x equal to a plus b and y equal to x minus c, right? So there are some inputs are coming, a plus b, right? And the second thing is y equal to x minus c. And if I want to implement this using this data flow graph, this will be the architecture. I think it is visible. I think it should be easy to understand, right? So in the first node, we call it as a data flow node. A and B are the inputs because the input arrow is given there, and there is an adder unit is there. So A plus B will be added at that, and which is named as X. The output of that first node is called X. And in the second node again we are going to have a subtracting function. So X and C are the inputs. So the operation X minus C will be performed and the answer will be given to Y. So I think here you can see the two equations, X is equal to A plus B and Y is equal to X minus B. So the same thing has been implemented using this particular diagram. And in the DFG model, a data path is the data flow from input to the output. What type of manipulations are done in between. And a DFG model is said to be a acyclic DFG if it doesn't contain multiple values for the input variable and multiple output variable for the given set of inputs. Feedback inputs or events are examples of non-acyclic. So as acyclic means there will not be any feedback or loops, right? So there will be an input, then some data processing is done and some output is given. There is no feedback. That is, part of the input is given back as part of the output is given back as the input. That will not be available in the case of acyclic case. And a DFG model translates the program as a single sequential process execution. So the data comes in it's getting processed and the output will be given. So it's a single sequential process execution type is followed. The second one is the control data flow graph. Of course, it is very similar to our data flow graph. The only difference is the execution will be controlled based on some parameters or some values. So some sort of controlling operations or conditional operations incorporated in the data flow graph, then it is actually called as control data flow graph. The control DFG model is used for modeling applications in the involving conditional program and execution. Already we have seen this. And it contains both data operation as well as control operations. So both the things need to be done. Initially there is no control operation in the previous case. Only the data operation is there. But here, since there is a control, so we have to first control it and we have to do the data manipulation. Both things need to be carried out. And the CDFG uses a data flow graph as element and conditional constructs as decision makers. So it's a normal, this DFG, data flow graph, but there will be some more additional conditions based on some expression will be executed, something will be there in it. And CDFG contains both data flow nodes and decision nodes, whereas DFG contains only the data nodes, right? Because here there are two things. One is actually control operations need to be done, data manipulation need to be done. But in the case of DFG, only the data manipulation need to be done there. Right. Now for this, we can take a simple example. Like if flag equal to 1, then x is equal to a plus b. Else y equal to a minus b. So if the flag value is 1, then I have to calculate the addition, and if the flag value is not equal to 1, suppose if it is 0, then I have to process y equal to a minus b, right? A subtraction operation need to be done. So I think this diagram is there using a diamond block, right? A normal checking, if checking block, I can use it. And this diagram of course gives an example about the CDFG, right? So initially the flag is checked, and if the flag is true, I think at the bottom side you can see a and b are taken and adder is there. So the addition will be performed and the given output will be given to pin number y, or the output port y. Suppose if the flag is not equal to 1, right? Either it can be 0 or it may have some other state, like is a input, the high impedance state, whatever it is, then immediately if the value is false, then the data will be given to the second node, right? And the a and b will be taken and the subtraction will be performed and the output is given at y. I think this diagram is self-explanatory, you can easily understand that, fine. A real-time world example for modeling the embedded applications using CDFG is capturing and saving of the image to a format set by the user in a digital still camera, right? So here everything is data driven. So one example is actually a digital camera, right, where we are going to take the pictures and store it in the digital domain. So that is actually a simple example which we can have an idea about this control data flow graph, right? Now the analog front end converts the CCD sensor generated analog signals to digital signals. So the CCD sensor normally generates an analog signal which needs to be converted into digital signal, fine. The data from ADC is stored in a frame buffer, right? Because supposing if there are plenty of data coming, processing all the data may not be sufficient, so it has to be stored in a frame buffer, and which performs various operations like auto correction and white balancing and all those things. So some basic operations can be performed in the stage 1 itself. The stage 1 is actually the before that ADC, all these processes are done. And the decision on in which the format is stored, say for example the images can be stored in JFIF, TIFF, JPEG, BMP, everything is there. So suppose if I want to do if you want to store it in a JPEG, then the raw data should be converted into a corresponding JPEG file, right? So some sort of encoding operation or decoding operation need to be performed for converting one type of image to another type of image, right? Say for example BMP to JPEG, JFIF to TIFF or PNG, whatever it is, right? And the next one is actually the state machine model. And in the case of state machine model, there will be some finite states, right? And by actions, the system state will change from one state to some other state based on the input or based on the state. Already we have discussed Mealy and Moore state machines are available there. Fine. So when we consider